Introduction. So, good morning, Director IIST Dr. V.K. Dadwal, Professor I.V.N. Krishnamurthy, Registrar IIST, Professor, Outstanding Professor and Dean Students, Professor Chandrasekhar, Outstanding Professor and Dean R&D, Professor Raju George, uh, Professor Samir, Head of the Department ESS, Professor Ramarao, very promising researcher in IIST as well as a coordinator for this event, and the distinguished attendees of this very prestigious event, GeoConnect 2020. So I'm thankful for having invited over here to give my perspectives of how to improve employability of students. This is one of the very important aspects of today's academic sector in India. Now, why do we need that? This is actually the essence of a survey called National Employability Report by the industry corporations. And they found in 2020, very recent, that only 3.84% of engineers are employable in software-related jobs at startups. And in specific areas such as AI, machine learning, data engineering, etc., only 3% of engineers process new age skills. Okay? And in comparison to us, US has 4 times more engineers with very good programming skills. In fact, you should remember that the US is 3 times less than us in terms of population. We are 3.5 times bigger than US. If you compare with the Chinese engineers and scientists, only less than 10.35% have coding issues, whereas we have a large percentage of students not able to do good hands-on activities with error-free code. Now, more importantly, one of the aspects that they have come up with is students doing something other than the class lectures. So the industry in India found that only 40% of engineering graduates end up doing internships, only about 1/3 of students do any projects beyond the coursework. So, which means that vast majority of our students do only the coursework and they get a degree out of that. So the areas such as remote sensing and GIS include the areas I have just now mentioned, which are affected by the poor employability scenario of our engineers and scientists, like AI, machine learning, data engineering, data science, and so on. Now, this is becoming very significant because, in fact, one of the recent statements from our own Director Dr. V.K. Dadwal, from his decades of experience, he says that a significant fraction of the space expenses, something like more than 85% budget expenditure or market is for applications on the ground. So the point is like, small fraction of the space sector is actually given a big more attraction in terms of launch vehicle development, spacecraft development, and so on. But when it comes to real value on the ground, the employability on the ground, applications on the ground, that's where huge, value creation or wealth creation is concerned. A satellite can launch hundreds of can actually create data, as just now we have discussed that millions of image points data. A launch vehicle can launch hundreds of satellites. Now, the data that is produced by a satellite can be used for a large variety of applications. That is actually the focus of a large number of industries today. But the question is that how to train the students to do better on remote sensing, GIS, and related areas. Okay, so my observation is that MT2 can actually be very useful because, as the Chinese proverb says, tell me I forget, show me I remember, involve me I understand. So that is where we actually have to focus a little bit on in our education sector. Now, one example I just put on here on a single slide is actually the example from Professor Walter Levin is a professor of physics in MIT, recently retired, but this is actually a representative picture from one of the videos that he had posted, where he usually demonstrate experiments of significant interest in the classroom itself. Here he is actually showing, a pendulum of certain size, and actually he sits on the pendulum itself. It is hung from the ceiling of the hall, and then he actually, goes, in both ways, in a resonance way, and then, he actually demonstrates some of the scientific principles of fundamental physics. People like it. If you are attending such lectures, you love to, learn more about the physics, and you, as a teacher, can really, contribute better to the students. So this is where, experiences or experiments or activities are brought into the class rather than a lecture that is delivered in a class. Okay. Now, MD2 stands for multi-track modular teaching methodology. This is where an academic course is divided into multiple parallel tracks, and each track can consist of a modular set of activities. So one of the important benefits of this activity is like it can enhance students' interest and engage him into the learning process, and it will also benefit the teacher to, develop R&D products. Now, as I mentioned earlier, there are multiple tracks. The course is divided into a small number of parallel tracks, and each track should be very carefully chosen so it will complement the other tracks. And depending on the needs that you identify as a teacher, the track shall be identified. So if you want a teacher, if you want your students to develop a certain skills, you can define a track for that. And the diversity of tracks will help, hold the right skills for your students. You can have optional tracks or mandatory tracks as you actually find it necessary. And within the track, you should have, several adaptive modules of activities. This is not like, sitting in a class and attending the lecture, but they, do certain activities. That some of these activities can be very simple, but it can be complementing the lectures that you deliver. You can give flexibility to students by having, optional modules and optional activities. It's very simple and very effective strategy. Usually the track one in this class is actually a lecture track, where the syllabus defined in terms of modules, units or chapters can actually be delivered in the track. And in parallel to that, you define certain activities. For example, maybe you define track 2 as a GIS data set collection activity. And when you do a GIS data set collection activity, what happens is students get different stages of development. Module 1 does some sort of a data set, initial data set collection activity, then a specific kind of data set collection. And at the end of the course, as you pass several modules together, they would have done quite a good amount of work in data set collection activity itself. Now, another track, maybe you will do some sort of interesting experiments inside classroom or outside classroom or on a field experiment. You may define a few modules. So these modules can actually enhance the learning that you try to deliver in the lecture track that you do. So when I did, in 2012, I have done a seminar track. This was the first time that I have formally started this. And I also have asked a track 3 with the wireless mesh network testbed development. And this testbed was deployed in one of our buildings for students to learn how to build real world testbeds. But subsequently, I tried, improving that with the 4 tracks, where track 2 was actually for a paper writing preparation, because many of our students were lacking the skills to publish papers. So I had created a track to train them to prepare a write-up that they can use later for their own publication requirements. Then another track was actually different track for testbed development. They really build a network testbed to do real world experiments. In fact, what we have done in 2012 and 24 and 2012 and 2014 are actually now available in markets by some of the companies. You might recall wireless mesh routers that is now available in addition to wireless routers for home purposes. It was not available at that time when we did in our classrooms. Now, one track I have defined in 2040 for research project where they do simulations or theory or even experimental evaluation with the results with the optionality for publications. Now, in 2016, I have customized the tracks for building and a third track for building an R&D prototype, which was essential for our research group to submit as part of a DST project. So they not only developed a prototype R&D system in various stages, different modules, but also I have asked them to create documentation as part of another track. Now, the reason for creating a separate track for documentation, in addition to having part of the original development track, was helping students to understand the importance of documentation. You see, otherwise, what happens is students will develop some programs and they will just throw the program away without having proper documentation available. Having a track separately defined for documentation, they were able to realize, yes, this is a specific and important activity and they have to learn. So that way, you can communicate the importance of certain activities by defining that as a separate track, even if that is a very, very small track with a few activities. So they not only developed a prototype research system, but also their documentation in as part of two tracks in addition to the lecture as well as the research. Now, you can define appropriate tracks for your courses that can substantially complement the lecture track you do. Say TIA software development track. This is bigger than an assignment because it runs parallel to the course over a period of a semester, quarter, or a year-based course. You can actually carry part one in one course and part two in another course. So if you do a master's program and you are teaching a part one course in first semester and part two course in second semester, you will be able to continue the track into the second semester. So you will be able to make a substantial contribution to the software development activity with the help of students trained in that track. Literature survey track seems a very silly track, but I find this very, very value adding track for our students, especially if they do in a course to have significant benefit when they do come for the final semester project. Even if I example a data collection track, as I mentioned once before, data collection track is a very important track where they help to learn data collection, because they will be able to spend some time over the entire semester with the different types of data collections. Eventually, they will know how to search and find data, how to classify the data collection, what kind of specific kinds of data sets are available, and how to use them for their further research. If you do this kind of a data collection track in the first or second semester of a master's program, the benefit will be seen when you are supervising them for the project in the third or fourth semester master's program. So even in one of the courses that I have done, I have actually defined a data creation track for OpenStreetMap, where my students actually collected some amount of data in and around Valiamala that could be uploaded to OpenStreetMap, which is actually very useful for road network analysis, delayed tolerant network analysis, and so on. In fact, you may define using the national data sets available through Bhuvan to help create a new data sets, help identify the geospatial points and other information. So you can sustain these activities across different semesters, across different batches in a consistent way that we can do. So many times, what we can do is experience multiple dimensions of learning by defining tracks, which cannot be easily done when you have only physical lectures. In fact, this is not easy to accomplish in a non-track based system where students may have certain ambiguity and lack of clarity when we mix many things together. So, for example, when you define a track to asset mapping and data analysis using Bhuvan, so you may define appropriate modules so that they will get exposed to Bhuvan and they will be able to conduct data analysis, data mapping, experiment, and so on. Even, track 3, even though it's a slightly less involved track, you can enable them to do crowdsourcing by first studying the interfaces of given resource, and enabling the crowdsourcing, tool sets, and getting the data sourced and geolocation coding carried out, and updating the crowdsourced data to the Google database. So that way, they will get exposed to this important resource available to all of us and opened by the government. So students are better trained for employability to do that. So many times, you want to do small experiments. You can define that as a experimentation projects on Google 2D data set. Okay, and you may decide, whether to add a third track or not. In fact, having a third light track can actually add a significant value. For example, if you have defined track 2 as an experimentation projects on Google 2D as the track is running, so you can also do a small programming track on 2D to 3D conversion. So they will get exposed to how to contribute to even 3D data sets too. So that way, it will give specific direction or specific capability of learning to the students that you recruit. If you have an ISRO scientist, you can actually specifically give him a track activity that suits him, which may be optional for other students. It might not be easy to have a very large number. You have to decide on a very small, feasible number of tracks. So what I have done is, for an X credit quarter-long course, you can have X+1 tracks. And for an X credit semester-long course, you can have up to an X+2 tracks, because it will help you manage the course very easily. And you can also assign appropriate credit in some of the 4-credit courses of senior undergraduate or postgraduate course. You can actually give 1 credit for an important track or a certain points as allowed by the university for appropriate credit enhancement. So within the track, you give modules. So the activities should not be continuing without having an end within the track. So they should have various modules, because some of the students will be able to complete each module successfully, and they should feel happy about completing that. Then only they will be able to continue with the rest of the activities. So the modularity within the tracks is very important, and you should be able to adaptively add or delete modules as the course progresses. You may actually introduce optional modules to help faster learners to do better, while many of the gifted and talented education system in the world, particularly in the US and Europe, students are allowed to learn at their pace. So that can be easily accomplished in a multi-track modular teaching or MT2 system. Now, as I have mentioned earlier, some of the modules may have a dependency. Say, for example, only when you complete certain modules in the lecture track, you should be able to allow them to start a prototype building activity. In fact, for me, only after covering certain portions of the lecture track, the prototype building activity could be done. So that is what is called the synchronous track. For example, only after completing this module, say M1, the M1 of track 2 can M1 of track 2 can be done. Only after completing M1 of track 2, M1 of track 3 can be done. So that way, you may have synchronous or asynchronous. For example, so the track 1 here has modules which may be asynchronous and not depending on the capstone project track that you may be defining, or the literature survey track that may not have a dependency. But small GIS experiments may have a dependency on the lecture track. So that way, the modules may be synchronous or asynchronous depending on their knowledge level required, subject that you cover, and the definition required. So I found that this will improve the quality of teaching. It will enhance the students' engagement with the subject. It will give very good understanding on certain directions of the course. Students' confidence will be much better. And more importantly, when they do real-world activities, their fear to apply their knowledge will be removed too. So that's how we can actually improve the employability of students. And for teachers too, the teachers should have good exposure. And if you do not have good exposure while using MT2, you will actually better and faster in teaching that particular subject. So if you practice MT2, you are forced to prepare better and go ahead with the teaching. So there are many possibilities for introducing track-based teaching in. One is that you can actually create open source software development. As I mentioned earlier, multiple courses, multiple student batches, and multiple years can be used for a teacher to develop a software module to accomplish. In fact, LIDAR software development in one of the current tracks on computer architecture, we have a project track where students are actually developing radar for automated development. And in fact, temporal flood map variation. Now, floods happen over so many years, and how it varies over decades is a very important thing. We have huge amount of data now opened up by the government, and this is a time that as teachers we should be able to give our students this information. So. So that they will be able to benefit. Now, in fact, there are so many possibilities. Hyperspectral remote sensing track where they are exposed to hyperspectral experiments, data sets, and do 3D object detection, algorithm development track for forest fire detection, and so on. Deep learning, in case if you are taking a GIS related course where the curriculum is not covering deep learning, then you can create a track for supplementing that information. Decision support system, it's very, very important system for many of the GIS based applications. Flood modeling and early warning track. So you will be able to appropriately create a track that suits your needs. So your students will actually develop a better capability for employability. So in summary, multi-track modular teaching helps multiple dimensions of learning, defines a course in the multiple parallel tracks. Each track can have an adaptive set of activity modules that will be very useful for students. And some tracks can be very light, some modules can be optional, and some modules can be challenging where they may have an open-ended activities too. So the teacher will also be developing himself in the subject if they are not already good in the subject. So that's also very, very important. So let me close here as we are already 10 minutes later. If you have any questions, you can ask me now, or you can actually email me at this email address. So the way how this technique can be effectively used as described in this textbook based on the instructions of the MHRD officials who asked me to write this up and put it in some sort of a book. Thank you all. Thank you for listening, and thanks the organizers for having given me this opportunity.
Any questions? Any questions from the participant side?
I have one question. I'm Padmavati. This is regarding the faculty. So before we put these courses and things tracks into for practice for the students, maybe the faculty should first experiment on the data that is there. Is there any availability? I heard there is Bhuvan data, but where can we find this data, and how do we verify whether that our algorithm or these things, whatever we have done is right? Do we have the ground truth and other information?
Yeah, this is a very important question because we have opened up a lot of data sets. We, in the sense that Department of Space, Government of India, and so on. But still, many of our faculty members and researchers are not aware what is available to them. So one of the important methods that you can ask about Bhuvan is to contact NRC. In fact, Dr. Vikat Adwal and Registrar Professor Krishnamurthy were actually leading that center, played a major role in opening up the data sets and making it available. Now the NRC center is headed by the current officials. They might be able to give. They have a, I think, public interface to contact and get that. And they may even have the data sets available. When I just looked up Bhuvan data set sometime back by visiting their website, I was able to access a lot of information about the status of some of the projects they have carried out for the Mahatma Gandhi National Rural Employment Guarantee Program and so on. So they have already opened up through their web interfaces in the form of downloadable or accessible through the browser. But other data sets, that you do not know can be defined as a data set collection track in your course. Students and you together can actually develop over a semester. So you will be surprised by the amount of data that students will collect over a course. So by the end of the course, this question will be more satisfactorily answered than how I can answer this. So second question, whether you need to experiment with the data set or not. Yeah, for doing this kind of courses effectively, the teacher has to have certain experience, but that need not be on the first time when you offer this course. Okay, let me give one example. In one of the MT2 experiments of my course, I have actually asked students to get to know a simulator, which was actually not well known to me at that time. So we needed experienced people to do. So I invited two experts to actually give invited lectures for that particular track, training the students on that particular simulator. So I learned this simulator while the experts gave the lecture along with my students. So that way, so when I repeated that for the subsequent year, so I am able to handle it all by myself because conducting this course have actually gave me also the opportunity to learn what was unknown to me until that time. So that is actually very good way. That's what I have mentioned. The teacher will become an expert if he is not already one, if you follow MT2 strategy.
There is a question from Sarida P. Sir.
Okay.
Sir, you speak of multi-track modular teaching methodology for multi-student sessions. Do you believe the same outcome can be achieved for a session with a small strength of participants in the bottom tier of Bloom's taxonomy?
Yeah, this is actually, I mean, MT2 is actually meant for, the higher tiers of the Bloom's taxonomy, especially the highest tier of Bloom's taxonomy is to be creative, to advance the state of the art, to do actually research or R&D. So that level activity can be carried out if the class strength is small. Okay, especially if you are teaching a PG class or a UG elective class where the class strength is manageable, then you can do wonders with this technique. Okay, but if you have a very large class, then individual attention cannot be given to each and every student. So you need to have teaching assistants. Okay, so you need to have for every 20 student one teaching assistant required to carry out to this MT2 strategy effectively. Now, to answer your question, for the students are at the bottom level, say, for example, an engineering college, a self-financing engineering college, where students are assumed to be bottom. But you can still improve the employability of them by creating appropriate tracks. So they learn to develop skills in that complementary direction in addition to the lecture track. So that way, you will definitely be able to do better even in large classes. But in small classes, you are guaranteed to do better. That much, you will do wonders with the